In lesson 7.6, we're going to discuss exponential functions. Let's first start by defining what an exponential function is. Pause the video and copy the definition. We're going to first start by looking at some tables so we can compare linear functions with exponential functions. Please write these down at the bottom of the second page of this lesson. If we look at the first linear function, we can see that the y-intercept is at the point 0, 0. Remember, all y-intercepts have an x value of 0. If we look at the pattern in the y column, we can see that every time the values are increasing by 2 as the x values increase by 1. We find our slope by finding the change in y over the change in x. Every time it's 2 over 1, so the slope of this function will be 2. We can then put it together and write the equation y equals 2x plus 0. Remember, we don't need to write the 0. We can leave it just as y equals 2x. Let's look at the second one. I can see again that the y-intercept is at 0, 0. This time, the pattern shows that we are adding 1/2 each time in the y column as the x's increase by 1. So our slope is going to be 1 over 2, or 1/2. I can put this one together and write the equation y equals 1/2 x plus 0, or just y equals 1/2 x. Now let's check out some exponential functions. Here the y-intercept again is where the x value equals 0. So in the first example, my y-intercept is at 0, 1. The pattern in exponential functions is not an addition, but now I can see that it's a multiplication of 2 each time down the y column as the y values increase by 1. So my pattern is going to be multiplying by 2. This shows growth, and the equation will look like this. Y equals the y-intercept times the growth or decay pattern to the x power. In our second table, my y-intercept is at 0, 1, and I can see the pattern is now multiplying by 1/2 as the x values increase by 1. Because it's multiplying by 1/2, this is going to be a decay. Our amount will be getting smaller. So the equation would be y equals, again, my y-intercept of 1 times 1/2 to the x power. Let's compare the shape of the graphs, the patterns we just found in the columns, and the equations of linear versus exponential functions. This is section 2 in your notes. The shape of a linear function is a line. If the slope is positive, we know that the line increases from left to right. If it's a negative slope, it will decrease from left to right. An exponential function will show a curve. If it has a positive growth factor, the curve will go up from left to right. If it's a decay, then it will go down from left to right. The pattern in the y column for linear is adding the same number each time. We saw that the exponential functions show multiplication of the same number each time. Our equations for linear functions look like y equals mx plus b, where the m shows the slope and the b shows the y-intercept. In the exponential functions, the equation looks like y equals a number times another number to the x power. Let's break down those parts of an exponential function. The a value is always going to be your y-intercept, and it's going to represent the initial or starting amount. The A must be greater than 0. The B value is your growth or the decay factor. The B must be greater than 1. It cannot be equal to 1 if it's going to be growth. If it's decay, it's going to be between 0 and 1. Let's start graphing some exponential functions. We'll do this one together. We have the function f of x equals 2 to the x power. If we plug in the domain of -2, -1, 0, 1, and 2, I'll start by using -2 as my x. That's 1 over 2 to the second power, which gives me 1/4. 2 to the negative first would be 1 over 2 to the first, or 1/2. 2 to the 0 would be 1. 2 to the first equals 2, and 2 to the second equals 4. I'm going to bring my y-axis all the way down to the bottom because I can see that all of my y values are positive. When I plot my points, I have -2, 1/4, so a little bit above the 0, -1, 1/2, 0, 1, 1, 2, and 2, 4. I can see that it's curving upward from left to right. I could tell this by the function because it was a positive b value. Greater than 1. And I don't really know when I get to the curve how high it needs to go. I know this one will approach 0, curve upward, but I get to this point and I'm not sure where it should land on x equals 3. So maybe I add another value in. If I plug in 3, I have 2 to the third, and I know that gives me 8. So it can't cross the line until positive 8. So I'll go ahead and add another value in. I'll go over 3 and up to 8. And now I can make my curve more accurate. They need to be a nice swooping curve. We know that our lines never want to go vertical because that would not follow the definition of a function. You try example B. Pause the video, fill in your domain for x of -2, -1, 0, 1, and 2, plot your points, and make a nice smooth curve. By looking at the function, the b value was between 0 and 1, so I knew this graph was going to show exponential decay. When I plugged in my domain, I wasn't sure where my line was going to cross the line x equals -3. So I added another value in my input column of -3 and found the y value to be 8. My graph shows a nice smooth curve. I have arrows on both ends. The right side of my graph is gradually approaching 0 but never crossing. In example C, we have the function f of x equals 8 times 1/2 to the x power. I know that my initial amount is going to be 8. It's going to also be my y-intercept. And I can tell because the b value is between 0 and 1 that this will show decay. I first need to use -2 as an input value, so I'll have 8 times 1/2 to the -2nd power. That's 8 times 4, or 32. Next I have 8 times 1/2 to the -1st. That's 8 times 2, or 16. 8 times 1/2 to the 0 would be 8 times 1. 8 times 1/2 to the 1st would be 8 times 1/2, or 4. And 8 times 1/2 to the 2nd would be 8 times 1/4, which is 2. I can tell that my y values are very large and they're not going to all fit on my graph. So I'm going to change the scale. My y-axis is going to go by 2's. That way I can fit more of my points to show the nice smooth curve. Go ahead and plot your points. We're not going to be able to fit -2, 32, but it will help us to estimate where our arrow should point to. I can fit my -1, 16, 0, 8, 1, 4, and 2, 2. Because it's exponential decay from left to right, the value should be getting smaller. You try example D. Pause the video, plug in your input values for your domain. It's going to be 3 times 2 to the nth power. Remember, your 3 should come out to be your y-intercept. 2 is going to show growth. So from left to right, your graph should be increasing. Pause the video and complete example D now. In this example, I chose to add another input value of 3, again so I could see where to aim my arrow and where it should cross the vertical line x equals 3. Notice my curve is nice and smooth and that it's not showing a complete horizontal or vertical line so that it still shows a true function. Now let's talk about asymptotes. Copy down your definition now. Section 5 says to describe the domain and range of an exponential function. Remember that exponential functions have 2 asymptotes. Exponential functions have the 2 curves, and they have a vertical and horizontal asymptote. The domain is the set of possible input values, and the range is the set of possible output values. So with an exponential function, the domain will be all real numbers. Any number can go into the function. The range is all the possible output values. So for an exponential function, this is all real numbers where x is greater than 0, all numbers higher than the asymptote. Let's look at a real-world example. Suppose a culture of 2,200 bacteria doubles every hour. The function f of x equals 2,200 times 2 to the x power. It gives the number of bacteria after x hours. How many bacteria will there be after 5 hours? Try this one on your own. Pause the video and complete A, B, C, and D now. If we look at the function, we can see the initial or starting amount was 2,200 bacteria. It's doubling because of the B value. If we plug in 5 hours for x, we can find the amount of bacteria after 5 hours. And we can also see how many were there 3 hours prior to taking the culture.